In this problem, we are given a random vector with two elements, x and y. And this vector has a normal distribution with this mean vector and this covariance matrix. And for x and y, we'd like to find the correlation. The correlation between x and y are the covariance C, the correlation coefficient rho, and then we'd like to answer if x and y are uncorrelated, if they are orthogonal, and if they are independent. Since we know the distribution for this random vector, from this distribution, we can directly read off some of the parameters. For example, the first element of the mean vector, that is mu x. The second element of the mean vector is mu y. The first diagonal element of the covariance matrix is the variance of the first random variable, that is x. So that is sigma x squared. The second diagonal element is the variance of y, the second random variable. So we can denote that as sigma y squared. So we can write that directly. Also, the cross diagonal, off diagonal element, that is rho times sigma x sigma y, and it is equal to 3. We can also write that. Now, we know that the correlation is given by covariance plus mu x times mu y. Since we already know what C is and what mu x and mu y are, by plugging in those values, we get correlation equals 5. Similarly, we also know that the correlation coefficient is given by covariance divided by sigma x, sigma y. And we already know what C is, and also sigma x and sigma y are also known. So by plugging in those values, we get correlation coefficient of half. Now we need to answer if x and y are uncorrelated. So what we can see is that the covariance is not 0. If covariance is not 0, then x and y are not uncorrelated. And then to see if x and y are orthogonal or not, we need to look at the correlation R. If the correlation is 0, they are orthogonal. Since it's not 0, x and y are not orthogonal. Now, normally to answer if x and y are independent or not, we need to check if the joint PDF factors into the product of the marginal PDFs. But since we're talking about jointly normal random variables, we don't actually need to check that. We can just look if the covariance is 0 or not, because for normal random variables, uncorrelated and independent, they are the same thing. Since we already know they are not uncorrelated, we can also say that x and y are not independent.